Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to start discussion on LLM in Databricks. Okay, so already in our previous video we have explored LLM concepts in detail with AWS Bedrock and Snowflake Cortex, and I have already created this specific playlist where all the videos related to LLM in different cloud platforms you will be getting in proper order. Okay, if you are not aware of any fundamental concept related to generative AI or LLM, I will request you to go through at least this specific video, Complete Amazon Bedrock in 2.5 hours, where I have explained the fundamental concept of generative AI and large language models, starting from tokenization to embedding to RAG or retrieval augmented generation or multimodal embedding. All important concepts are covered in this specific video. And if you want to kickstart your generative AI journey in Snowflake, then I will request you to go through this first video at least, where I have explained how to perform intelligent text classification using Snowflake Cortex LLM. And then the same POC now today in this video we are going to perform with Databricks large language models or Databricks generative AI. Okay, so here this specific diagram is depicting any general flow for RAG application or intelligent text classification, anything like this kind of POCs or use cases, right? We are having our source data in Databricks world. It can be stored in some delta table, and as a first step what we need to do, we need to pick up some embedding model which will help us in converting our text data or image data to some higher dimensional vector data, right? And that vector data will be storing in embedding table, which can be another delta table in our Databricks platform. And obviously we are going to create a vector index on top of that table, so that way we can perform quick vector similarity search with some new data set, right? So this is the left side of the RAG architecture, which can be offline, and in the online part here this right hand side is available, where we are having some LLM application that can be chatbot or something, and user will pass some text or query. As a first step what we will do, that text we will pass via embedding model and we will get its vector representation, and then we will search in our vector database that what is the available data which is having highest similarity with that user input text data, and whatever existing data is having highest similarity, that top 3 or 5 records or rows will be returning, using which LLM model can reply to the user question and help in classifying the user question to a certain category, right? That way it will work. Now, without any further delay, we will jump into the implementation section, so that way all these things will be more clear to us, right? So as a first step what we'll do, we'll start a compute engine. So maybe this one, let me start. So here you can see our compute engine is starting, and here as a first step what we are going to do, we are going to drop a table with the name question data if it exists, because this example I want to show you with a fresh table, that's why I am dropping and then creating the table. This table will be having majorly 3 columns. One is ID, which is kind of primary key for our question. Then we are having text data and then category. So for example, the data might look like this. So if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, these are basically primary key kind of auto increment value for our question ID column. Then in the text, we are having these kind of questions like what is the capital of France, or name the tallest mountain in the world, or maybe what are the planets in our solar system, etc, etc. And the third column is basically category, which is basically indicating from which category this particular question is belonging to. For example, what is the capital of France? This is geography category question. Or if you consider this one, difference between classical and quantum computing, this is a technology question, right? But if you see explain the theory of relativity, this is a science related question, correct? So this is how we are having basically majorly 3 categories: geography, technology and science. Okay, and we are going to insert this dummy data in this question data table. As a first step we'll do this one, and then we'll be building such system which will help us in classifying any unknown question is belonging to what category. For example, if you ask what is Higgs boson or God's particle theory, right? So that time this specific question is not available in our table, but it is related to science or technology. We can understand obviously not related to geography related question. So using vector embedding, we'll try to classify that unknown question is belonging to what category. That is the POC what we are going to perform as a first step in our LLM journey with Databricks. So we'll start that, but before that, let our cluster get spinned up. So here our cluster is now up and running. So what we'll do, we'll basically first drop the table if it exists, and then here we'll execute this cell to create the fresh table. And here we are getting the table data because we have executed here the select star from question data query, right? So this is what data we have inserted. Now as a next step of our text classification, we should be knowing how to perform embedding, that is converting any text data to higher dimensional vector data. So for that, Databricks itself is supporting some embedding models or large language models just like Snowflake Cortex. Okay, so here if you see in the left hand side we are having SQL space, then data engineering space, and now here at the end we are having machine learning space, where you can see a tab called models, where you will able to see different kinds of model what our Databricks platform is supporting. Obviously you can add some fine-tuned model or open source model from Hugging Face, etc. And we are having one more tab called serving. So this serving endpoint is basically allowing us to call any large language models. We can create serving endpoints based on Amazon Bedrock model, Hugging Face model, or based on our fine-tuned model or any other models whatever Databricks has already by default provided us. Okay, and by default if you see lot of serving endpoints Databricks has already created. So we'll be exploring how to create serving endpoint later in our upcoming videos, but as of now let us try to use some already existing serving endpoint and try to solve this specific problem. Okay, so here if you see related to chat, some serving endpoints are there, and related to embedding this serving endpoint and this serving endpoint is there. So as of now for our this POC we are going to take help of this specific serving endpoint, BGE large. Okay, so here you can see that it can map any text to a low dimensional dense vector which can be used for tasks like retrieval, classification, clustering, or semantic search, etc. Right? And if you want to know how to use this serving endpoint, here you can get the use button. So either you can directly try in playground mode, or using curl command, or using Python code, or using SQL code you can call it. Because this is our first POC, so I am keeping it very simple. We are going to use with SQL. Okay, select, then AI query. Here you need to pass the serving model endpoint, and then here you can pass any text to get the vector representation or embedding vector out of it. Okay, so that's what I have done here. Select AI query, and then I have passed the serving model endpoint, and in the request I am passing the text, that is who discovered electricity, right? And if we run this one, what it will do, this SQL query will basically return one vector representation of this text who discovered electricity, right? This is perfectly fine. So now as a next step what we will do, we will convert all our this text data into vector representation using this kind of AI query. So that's what I have done here. Create or replace table question data vector store. So this is a new table what we are creating. Our first table can be bronze table, and this table is suppose silver table, like that way you can think of, which will store the vector representation for our text data. Okay, so create or replace table question data vector store as select question ID, text, category, that is all the existing columns. Along with that, the embedding vector representation for the text column we are creating, and the column name we are giving as embedding vector, and all the data from question data table we are picking up and then storing in question data vector store. Okay, so we'll execute this query now, which will help us in getting the embedding vector representation. So here you can see in the backend Spark job is running, and that is done. And now if I do select star from question data vector store, here you will able to see that first three columns are same like our question data table, but here in the fourth column embedding vector is stored. Okay, which is nothing but representation of our text to a higher dimensional vector space. And the vector dimension, if you see by scrolling below, here it is 0 to 1023. That means 1024 dimensional vector data it basically convert. Okay, cool. That is fine. I hope up to this. So I'll just quiz this part, and yeah, this is our current table, how it looks like. Now as the next step, what we need to do, we need to have some setup using which we can quickly perform similarity search on top of our this embedding vector. Kind of a vector database will help us in this case, right? Now Databricks has one service which can be useful for this kind of vector similarity search related use case, and that is available here. You need to go to compute, and then here you can see a tab called vector search. You can go there and here you can create vector search endpoint, and you can consider this kind of like a service of Databricks which can help us in performing vector similarity search, as simple as that. You can always create an endpoint by clicking on create button, give some name, and in advanced setting obviously you can create some budget policy to have a monitoring on how much cost it is incurring as part of our vector search process, and just providing all this information you can click on confirm. So it is going to take 5 to 10 minutes. So for that I have already created one vector search endpoint with the name test vector embedding, and if you go inside that, as of now there is no table or index we have created yet, right? So we'll be creating that now. So index is nothing but table you can consider which can help us in performing vector search. It is just like a pinecone table if you have worked with pinecone. Okay, so anyway I am not going to those because when we will do the experiment we will understand this easily. So index is not yet created, and we need to create an index basically for this vector search on this embedding vector column. So how to do that one we'll be exploring now. So for that you can go to catalog, and then you can go to workspace. You can find out your table where vector embedding is stored, that is question data vector stored, and then here you can see a create button, right? And in the second last option you can see vector search index. So on top of this table, if you want, you can create vector search index, and you need to give some information like index name. Here I can give the index name as first vector index, something like that. Now primary key in our table is basically question ID, so I'll be choosing that. Now vector search endpoint. So as I told you already, we have created the vector search endpoint, that is test vector embedding, so that one I'll be choosing. And then column to sync. Okay, so here basically you have to mention what all columns you want to sync in your vector search index. If you don't mention anything, all the columns it will be syncing. But if you want to mention some specific columns, at least primary key and the column where our embedding vectors are stored, those two, so obviously it need to sync. Apart from that, any additional column if you want to mention, you can mention. So as of now I am keeping this blank, so as a result all the columns will be synced in our vector search index, as simple as that. Okay, so I'm not choosing anything. And now embedding source. So in embedding source you can mention either compute embedding or any existing embedding column. So what this is indicating is Databricks itself can perform the embedding on the fly is in this vector search endpoint. Just you need to mention compute embedding, and then you have to choose the column on which you want to perform the embedding and the model using which you want to perform the embedding, right? That option you can choose. But in our case already we have generated the embedding vector. So I am going to choose the second option, use existing embedding column. Okay, and then we have to choose which column has the embedding data available, that is obviously embedding vector column, so I'll be choosing that. And embedding dimension, we have already seen that this specific model, that is Databricks BGE large EN, convert any text data to 1024 dimensional data. So here I'll be writing 1024, as simple as that. And the next one is sync mode. Either it is triggered or it is continuous. So triggered mode is like you can trigger manually this sync process, or in continuous case it will continuously monitor our table, and as soon as new data will be inserted in our table it will try to update our vector index also. So continuous will be little bit costly because continuously in backend some compute engine will be running. So I am not going to use that. I am going to choose triggered option. Okay, but here you can see it is throwing an alert that you should have change data feed enabled for your table to create vector index, right? So this one we need to do first. So maybe what I can do, I can execute this cell, alter table, this one, which will enable change data capture on top of this table. So it is done. And here, because it is not happening, so what I'll do, I'll close this window and maybe refresh once, and then I can click on create vector search index, and again give the same information, question ID, our vector search endpoint I am choosing, existing column, embedding vector, this is 1024 dimensional data, sync mode, triggered, and then here I can click on create. Okay, so this will create vector index in our this specific compute layer. If I just show you, here you can go to vector search tab, and within this one if you enter, here you will see one index got created, workspace.default.first vector index, whatever name we have given here. Now to create this index, it is going to take some time. Here you can see that it is creating some pipeline, and what this pipeline will do is like kind of it will read the table and then populate our vector index whatever we have created here, right? And if I scroll below, here you can see the pipeline ID as well. So if you want, you can open this pipeline, and that will take you to the Databricks workflow page, what I have already covered in my previous video. Workflow is nothing but helps us in job orchestration in Databricks. So here you can see it is having certain step using which first it will read the table and then it will update or refresh or hydrate our vector index whatever we have created. And I am guessing this is where the change data capture or change data feed we need to enable. So that way this pipeline will only refresh our vector index with the latest data whatever is available in our base table, instead of refreshing the whole data whatever earlier also got updated, right? So maybe you can intuitively understand for that purpose the Databricks team might have asked to apply change data feed on our delta table. So that is fine. So as of now, let our pipeline get completed. And even you can orchestrate this particular pipeline using this schedule button. You can configure that when this specific pipeline will run every day at some certain time, or maybe if you want you can provide some corn expression as well. So I am not going to schedule the pipeline as of now because this is we are just doing for POC purpose. I'll just manually trigger the pipeline if it is needed later. Okay. So that is fine. Let's wait for some time until our update status shows that the pipeline is complete. Okay. So here you can see now the status got changed and the pipeline is complete. Even if you want, you can see here that online index view, this job ran successfully. Okay, cool. So with this way we can understand our this index is updated. Now what we can do, we can go back to our notebook and it's time to perform some text classification. So how we are going to do text classification? It is a very simple code. Select star from vector search. So vector search, this particular function will help us in performing similarity search on top of our vector index whatever we have created. Now as a first step, we need to provide the vector index name. So in this case, the index name whatever I have given is this one, right? Workspace.default.first vector index. So I'll be updating here. So this is our vector index, and then in query vector we need to pass the embedding vector for the text which we want to classify. So here I want to classify the type of the question, that difference between Databricks and Snowflake. Okay, obviously we can understand this is a technology related question, but we will see how this similarity search is working. So we need to pass the vector representation of this text, right? So for that what I will do, I will get its vector representation using AI query and then passing the BGE model, like how here on the top we have done like this manner, AI query, then model them and then the request. Same pattern I have followed here. Okay, AI query, model them, then request, text. Okay, and then this query will return the vector representation of the text, and then we'll try to find out in our already existing vector index what are the top two similar vector. Okay, num result 2, that means top two most similar vector it will return. So let's run this query now, and here you can see these two records it is returning, and it is indicating that this question is having highest similarity with this existing text. One is difference between classical and quantum computing, another one is best practice for cyber security. And if you see, both category are belonging to technology. So from this existing category we can conclude that this question is also belonging to technology category, as simple as that, right? And it will also return the search score. So with respect to the first question, difference between classical and quantum computing, this question is having similarity score of 0.5, and with respect to the second question, best practice for cyber security, and this question is having similarity score is 0.4. So I hope you are getting this, that how we can perform text classification. First, we need to store known classes for some existing text in our vector database, and then for unknown text, if we want to classify, first we will get its vector representation, and then we will search in our index whatever top 2 or 3 similar records we will be getting. for that whatever category we will be observing, that category only we can conclude as category for this unknown text. As simple as that, right? So this is how you can perform intelligent text classification in Databricks using vector search. And this complete thing we have done using Databricks LLM features, not using AWS Bedrock or Snowflake, right? So Databricks also have these kind of services with which you can play with. And now let me show you a little bit incremental data processing also. So maybe let's consider as a first step in our bronze table where only question ID, text and category columns are available. These new records are coming 11 to 20. Okay, and now silver table is basically where embedding data is stored. So from the bronze table, what we'll do, we will only select the incremental data. So incremental data select, how we do, that is select star from source table where question ID is greater than select max question ID from our silver table or second table, right? So select max of question ID from this silver table. When we are querying, it will return that for this existing silver table the max question ID is 10. So we need to extract all those rows from our source table which are having question ID greater than 10. Greater than 10 meaning, if you see this table, I can write %SQL select star from question data. So I need to extract only those rows which are having question ID greater than 10. So that way incremental data we can easily extract from our this bronze table, right? So let me just execute this query and let me show you that it will only have incremental data, not the whole data. So here you can see question ID starting from 11. Okay, and using the AI query we are getting the vector representation for this new text data, and all we have to do is basically execute an insert query and insert this select query data to our silver table. Okay, so we'll do that, and that is the query what we have written here. Insert into our silver table. In these columns the data has to be inserted, and only for the incremental data I have performed vector embedding and I am storing it. Okay, so let me do that quickly. And new rows inserted is 10. And now if I do select star from question data vector stored or from our silver table, here you will see not only 10 but we have total 20 text for which embedding vectors are stored. And now as a next step, before testing with some new unknown text, what we need to do, we need to sync or hydrate our vector store or vector index. So for that purpose, what we need to do, we need to rerun this particular pipeline, right? So that one you can click by sync now. Okay, and here you can see our pipeline is going to start. So always you can check in this specific workflow tab, you can refresh, or maybe you can go back to pipeline. So if it is not showing here, not a problem. You can always open this pipeline ID in a new tab and check. So here you can see our pipeline is running, and all it is going to do is basically reading the new data from our table, and the embedding vectors and other columns it will be updating in the vector index. Okay, that is important for vector query operation. And then we'll be executing one more text, that is explain God particle or Higgs boson, and we'll see that with what existing questions it is having highest similarity. Okay, but before that, let our pipeline get complete. So here you can see the pipeline run is complete, and now indexed rows are having count 20, earlier 10, and this time incrementally 10 more. So as a result, total 20 rows are hydrated in our vector index, and now we can query for some new text like explain God particle or Higgs boson. And if we run this one, okay, so index name I need to update. So in our case, the index name is this one, and then we can run it now. And here you can see it is throwing that two most similar categories, science and technology, with respect to this question, which is true in one way, right? That Higgs boson or God particle is related to science and technology only. And if you scroll right, it is having more similarity with science, which is obviously intuitively true, and then second one is technology, right? So like this way, based on the most similar categories, you can take the mode value maybe, and then you can conclude that this unknown question is of this category. Like that way you can perform classification using vector embedding. So this is a quick start tutorial related to Databricks, large language models and generative AI, and this is one of my favorite use case. Even when I started explaining LLM in Snowflake, I have taken this intelligent text classification use case only, which is pretty simple and intuitive to understand. So that is why I thought to cover this in this video. In my upcoming videos, I will cover some more concepts around Databricks generative AI. So stay tuned for more interesting videos, and if you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.